Okay, number 4. So the complex number x equals 4i is a zero of this polynomial function. Find the remaining zeros of the function and write it in its linear factorization. So if they tell you one imaginary zero, then you gotta know that there is another zero that comes along with that. So the complex conjugate of this given zero would be x equals negative 4i. Now, there's actually a couple different ways that you could approach this problem. One way is to use synthetic and to keep breaking it down. And that's what we're going to do here. So I started with a degree 4 polynomial. If I go through synthetic once, I'll get a degree 3. And if I go through synthetic a second time, I'll get a degree 2, a quadratic, which I can always solve a quadratic. So let's do that method. Now you can plug in imaginary zeros in synthetic. Yes, you can. And that's what we're going to do. I opted to plug in 4i first. So I wrote the coefficients. Again, my degree of this polynomial was 4. So that little check is you should always have one more than that in that top row. So you should have 5 numbers. When I look closely, I'm missing the x cubed term. And I also don't have an x term. So that built-in check helps out a lot. So I go through synthetic, drop the first number, multiply, add, multiply. Now be careful here, I squared, we know that I squared is equal to negative 1. So this really is negative 16. And 13 plus negative 16 gives me negative 3. Negative 3 times 4i, add the columns, and then again, I've got negative 48i squared. And whenever your term has the I squared, it's multiplying that number by a negative 1. So that will change this to negative 48 plus 48, which is how we get that remainder of 0. This is a degree 3, so if I go through synthetic one more time with that other 0, I'll be able to have a quadratic that I can solve. Now, really important, when you're going through synthetic multiple rounds, always make sure you use your depressed polynomial from the last round, because you want to keep breaking it down. So I'm using these coefficients as that top row. And then I'm going to drop the first number, multiply, add the columns, multiply, add the columns, multiply, add the columns. So again, a remainder of 0 is exactly what we want. Because I started with the degree 3, my answer in this bottom row is a degree 2. It's exactly what I want. I have the quadratic. That was my goal, to get it to a quadratic, to break it down. So I started with a degree 4, and after the first round, I got a degree 3 polynomial. Then I used that degree 3 polynomial to go through synthetic another round, and here's my degree 2 polynomial. So I'm going to write it as that quadratic, 1x squared, it doesn't have an x term, minus 3. So think of all the methods to solve a quadratic. If you're missing that linear middle x term, square roots would be the quickest option that you have. So get that x squared by itself. Take the square root of both sides. Don't forget the plus or minus. And so there are all my zeros. I have 4i, negative 4i, positive root 3, and negative root 3. 4 zeros, my degree was 4. That's how I know that I found all the zeros. The other part of the direction says, write it in its linear factorization. So that will be our final step. If I have the zeros, all I need to do is set up my 4 parentheses, because it's going to have 4 factors, and I'll set them up with x minus, x minus, x minus, and a final x minus. And then I'm just going to take each 0 and put it in a parenthesis to write it as a factor. So x minus 4i, x minus negative 4i, you can see that's why I wrote it as x plus 4i. And again, x minus negative root 3 is why you see it written like that. And that's it.